Over the course of the last couple of days, we have been looking at parent functions that have been transformed with an a value, a c value, and a d value, and made a determination of what that would happen to the new graph. Today, we're going to look at graphs and write equations from those graphs. So this is the order that we're going to use to do that. First, we're going to recognize what that parent function would be. Then we're going to find if there are any horizontal or vertical shifts of the critical point. On the next page here, I'll talk to you about what the critical point of different parent functions would be. Then we're going to determine if there's a vertical reflection. In other words, was it flipped upside down? And finally, we're going to find if there's any vertical stretch or compression, and if there is so, we're going to find the value of that stretch or compression, and this is the formula that we're going to use to do that. And I'll give you an example at the end so these steps will make sense. Okay, first I need to talk to you about what critical points are of a graph, though. Okay, so I have four parent functions here, and the critical point of the first one, which is quadratic, would be this vertex right here. So we'll be looking to see if the vertex of the parabola moved left or right or up or down. Okay. The critical point of a cubic function will be that middle point right there. Okay. The critical point of a square root function, this one down here. Sorry about that. Critical point of this one would be this point right here, where it originates from. Sometimes the critical point of a function that we use in graphing are those asymptotes. So on this one, if you have one that's a rational function, with the x on the bottom, we'll actually be looking to see if these asymptotes have shifted to the left or the right or up or down. Okay, let's do an example. Okay, I have a transformed function right here. It's a v-shape, so that tells me that the parent function of this graph is absolute value. Okay, so y equal absolute value, that's my parent function. Next thing I'm going to look at is, has my critical point moved? The critical point on an absolute value function is this vertex right here. Well, let me put the parent function on here so that we can do some comparisons. Absolute parent function would look like this. It's always good to have something to compare it to. I think you have maybe the parent function on your paper. Okay, so here's my parent function that we're going to compare it to. That ought to be far enough. Okay, so I'm going to look to see how this point right here has moved. It has gone 1, 2, 3, 4, 5, 6, 7 units to the right. So I know that my new equation is going to have x minus 7. Remember, what happens inside the function is the opposite of what we would think. Minus 7 indicates right 7. Okay, it also went up 1, 2, 3, so I have plus 3 here at the end. Okay, now, next, I recognize that this is flipped upside down, so I know I'm going to have a negative up here in the front. And this new graph looks a little bit narrower than the parent graph, so I know that I've got a stretch. Okay, here's how I'm going to find what number goes right here. I'm looking at my parent function, and I see that if I go over 2 units here, and it doesn't have to be 2 units, it could be anything. If I go over 2 units here, the height of my graph right here, when I go over 2 units, is 2. Okay? When I go over 2 units on my new graph, the height is 1, 2, 3, 4. This new height is 4. So I find that A value by doing the new height, 4, divided by the parent height, which is 2 in that same place. So 4 divided by 2 is 2. So I know my A value is 2. So this number right here in my transform function is a 2. So the function of this graph is y equal -2 absolute value of x minus 7 close absolute value plus 3. Okay, let's double check it. Okay, this minus 7 means that my vertex has shifted right 7. 1, 2, 3, 4, 5, 6, 7. Check. This plus 3 means it's moved up 3. 1, 2, 3. Negative indicates that it is vertically reflected. In other words, it's flipped upside down. That's good. And now then, I want to see that if it's been stretched by a factor of 2. Well, I moved over 2 places here. I'm just going to check it by moving over 1 place. If I go over here 1, that right there has a height of 1, correct? If I come over here 1, that now has a height of 2. It is twice as tall as it used to be, so this number is good. Piece of cake. We just wrote the equation of a transformed absolute value function.